Well, good afternoon, good evening, or good morning, depending upon where you are in the world, and welcome to today's webinar. I'm Charlene O'Hanlon, your moderator for today's event, and I welcome you. We have a great webinar on tap with some really interesting information, but before we get started with that, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you'll be able to access it on demand. Following the event, we will be sending out an email that will contain a link to the webinar that you can access on demand. And with that, we'll go ahead and get started with today's webinar.
Hi, everyone. My name is Thomas Robinson. I'm a solutions architect at AWS. I work with our partner community on building solutions that help our mutual users. Today, I'm going to give an overview of AWS container services to help give a better understanding of solutions available to run on AWS. After that, we'll dig into container security, adapting the shared responsibility model to an environment running containers. Then I'll hand over to Dan Hubbard from LACEWORK to talk about how they can help you meet your portion of those responsibilities. Starting with our AWS container services, this landscape covers a broad set of products. In order to orchestrate your container deployments, we have Amazon Elastic Container Service, or ECS, and Amazon Elastic Kubernetes Service, or EKS. ECS and EKS make it easy to deploy, manage, and scale containerized applications on AWS with the Amazon-created orchestration through ECS, or Kubernetes and EKS if you prefer that. You can currently run your containers on these services using either the EC2 launch type, where you get to manage the underlying instances on which your containers are running, or you can choose to run your containers in a serverless manner with the AWS Fargate launch type. Finally, we provide registry services, Amazon ECR, where you can store your container images. So you get to choose whether ECS or EKS fits for your orchestration layer, then choose where you want to run the containers. With Fargate, you package your containers, set CPU and memory requirements, configure networking and IAM policies, and launch. You don't have to manage the underlying EC2 instances. If you choose EC2, you get access to the instances running your containers, which gives you more granular control of their configuration, but requires more management for things such as auto-scaling those environments. We'll dive into what this means from a security perspective a bit later. So why use these services instead of running your own container orchestration? Our customers love AWS container services because it not only provides the broadest set of capabilities for them to manage our containerized applications, but it's also the easiest place to run your containers. Our services are deeply integrated with the AWS cloud, so you get all the benefits of IAM security, VPC networking, and load balancing while enabling your DevOps workflow through developer tools. Our container services are also included in our ISO, HIPAA, PCI, and SOC compliance efforts, making these services easier to use in regulated environments. In the last couple of years, we've seen great adoption for production use cases on ECS. Our active users are up by more than 450% since 2016, and we're managing containers across millions of instances each month. In fact, we're witnessing an incredible transition to containers and customer scaling on Amazon ECS, whether it's Expedia running the travel platform or Mapbox powering map data for some of the most popular websites. Amazon ECS enables these customers to be able to run containers at scale, and indeed we see hundreds of millions of containers launched every week. A survey in 2018 by the Cloud Native Computing Foundation found that 51% of Kubernetes workloads run on AWS today, and for containers as a whole, this number is 63%. Before getting into security, I'd like to talk about a few services that are relevant to building microservices on containers in AWS. If you really get into building microservices at scale with lots of APIs, you may find that it's not enough to manage these APIs individually, especially since these microservices environments can get very large. At reInvent 2018, we launched AWS Cloud Map as a way to discover and communicate with the various APIs and microservices that might make up your application. In the same pattern, we want infrastructure support that makes it easy for your developers to use simple DNS names SDKs, or APIs to discover and connect to the APIs that make up your microservices. Related to that, we know that sometimes you have to manage network communication faults or software updates and things like that. And that's why we launched AWS App Mesh. App Mesh is a service mesh that makes it easy to monitor and control your microservices running across AWS. We launched it so you can have a managed infrastructure that we provide for you that you can use to deal with these network conditions and can be used across multiple clusters, multiple orchestration systems, and even across multiple VPCs. Now let's talk specifically about security. We'll frame that discussion around the shared responsibility model and adapt that to container workloads in the cloud. This is a shared responsibility model, which is, if you've been involved in AWS security for any amount of time, you've probably seen before. Covering the bottom part first, AWS is responsible for the security of the cloud. And what that means is we're responsible for protecting the infrastructure that runs all of the services offered in the AWS cloud. This infrastructure is composed of the hardware, software, networking, and facilities that run AWS cloud services. This includes maintaining separate regions and availability zones, ensuring that when you select a region to host your data and applications, that they stay within that region. This can be extended to compliance controls, where AWS fully inherits physical and environmental controls for you. We share some responsibility, such as patching, configuration management, awareness, and training. For Amazon's portion of this shared responsibility, this extends to patching and configuration of the infrastructure layer and the training of our employees, where you're responsible for patching and configuring your applications, databases, and operating systems, as well as training your own employees. The customer is responsible for the items seen on top. Some of these don't change when using AWS Container Services, so let's talk about those first. Starting with customer data, it's important for you to understand how to handle your customer data, and that means classifying and securing it. AWS does not access data you store in the cloud. AWS provides capabilities for you to encrypt data in transit and at rest, both integrated into our services like EBS and S3, as well as the ability to store key material for encrypting your objects through KMS or Cloud HSM. We also have services like Amazon Macie to help you identify what type of information you're storing. In the end, it's your responsibility to utilize these services in a way that helps you classify and secure your data. In AWS, you control how your users are authenticated and what authorization they have into AWS. AWS provides the identity and access management service for you to define users, groups, and roles, and the permissions they're authorized to perform through policies. You can utilize federation to tie authorization into a directory service or utilize single sign-on through Amazon SSO. It's up to you to use these in a secure manner, applying policies in a way that meet least privilege, rather than allowing all users administrative access to all resources. Customers are also responsible for managing their network and firewall configurations. We provide capabilities to build public and private subnets through VPC, apply network access control lists to those networks, and security groups to the resources within them. We also provide protection from common web exploits and DDoS attacks through AWS WAF and Shield. It's up to you to configure those services to restrict public access to private resources and ensure resources can only communicate with the services they need to. One thing that we really try hard to do with our AWS container services is make sure that these constructs remain the same when using ECS and EKS as they are when you're using native EC2. When you look at things like IAM and network and firewall configuration, I'd like to point out the same capabilities you're using with IAM roles and network interfaces also exist within the ECS service. You can apply IAM roles to specific ECS tasks for those which need AWS credentials. You can also specify network interfaces and security groups at the task level, so you aren't forced to be overly permissive on the instances that pass traffic to containers. This is a key difference when deciding to use an AWS container service instead of running your own orchestration solution. Now, How has the shared responsibility model changed with AWS Container Services? Starting with ECS and EKS running on EC2, the customer is responsible for their Docker images running their applications. The platform is managed via the ECS configuration, and the operating system remains part of the customer responsibility. We also call out that instance scaling for ECS, as you need to manage how your underlying cluster of resources scale to meet the demand of your containers. AWS becomes responsible for the control plane for ECS or Kubernetes. When thinking about what this model would look like if you were hosting your own container orchestration tooling on EC2, this item would be in the customer responsibility section. So not only do you have to manage a little bit more on the network and authorization side, but you also need to manage the ECS control plane. As with other items in the customer section, we provide solutions like auto-scaling and the container registry to meet some of the requirements, but it is your responsibility to utilize them. Looking at Fargate in the context of the shared responsibility model, it looks much more like a serverless model such as AWS Lambda. Fargate helps move additional items to the AWS side of the shared responsibility model. We begin to manage the cluster itself and handle the instance OS, as well as scaling resources running your containers. You only need to manage the images and the configuration of those containers, and we handle all of the underlying infrastructure. Now I'll hand over to Dan Hubbard to talk about how LACEWORK can provide solutions for your responsibilities when running containerized workloads. Take it away, Dan.
Thank you very much, and welcome everybody. So let's talk at the high level. You know, if you're running a container orchestration system or just containers on their own, whether it be public cloud or not, there's a number of unique kind of new problems that you need to solve that become your responsibility. And of course, you know, as Thomas outlined, depending on the services that you are managing or not managing, that responsibility is either up to you, if you're managing it, of course, on your own, and or, of course, up to the provider like AWS with ECS, AKS, and Fargate. But first and foremost, of course, at the workload and container side, you know, you have to protect yourself against, you know, intrusions. So there obviously, the host has an opportunity to be breached, or malware or abuse happening on the host. There's a number of kind of runtime and build considerations. And these really are about the application itself. At the end of the day, you know, the core reason or value that you're even running containers is so you can deploy your application. So you want to make sure that not just the underlying kind of management plane doesn't have vulnerabilities or risks or threats, but also, of course, your application, whether it's your web server, your email stack, your backend database, whatever it may be. So application visibility and, of course, vulnerabilities and runtime security all are heavily focused on kind of the runtime application side of things. The next is that you need to be able to investigate. You know, what happens if you do believe there's a breach or you get an indicator that there has been a compromise in some way? With that, you're going to have all kinds of questions. When did it happen? How bad is it? You know, how did they get in? You know, was there configuration that caused it, or was it a developer? Was it an insider or an outsider? So you have to be able to investigate the possible breach and or risk. And then, of course, there's a bunch of other kind of nuanced technologies like file integrity monitoring. That's really on the workload and the container security side. On the account security side, there's a number of really powerful tools that AWS provides, but there are some things above and beyond that that allow you to look at your developers' access, where your developers are coming, and how they're accessing your infrastructure and what they're doing when they access the infrastructure. So those are things like, you know, are users, you know, are they doing things they've never done before? Your developers provisioning new services you've never seen before? Are they going outside of kind of applied or attempted applied guardrails? So visibility, of course, on the account security side is also really critical. And the ability to find not just the known attacks that could happen through accounts or keys, but of course the unknown and the things that you really want to know about. And lastly, of course, is compliance and audit control. Are we following the best practices across all of our infrastructure, whether it be things that are provided like CIS, which is a fairly trivial set of things, or more complex configurations that are key to my infrastructure that I really care about, whether it's NIST, HIPAA, FISMA, PCI, or just best practices. So the security choices, that you have when you're looking to do this are across really kind of 4 key areas. The first one is really what Thomas, outlined, which is certainly there's a number of really great tools that are provided by the CSP. The cloud service providers got a lot of great tools there. And I think it's more likely, what we're definitely seeing in our customer base, it's more likely that our customers using cloud service provider tools that are provided, maybe a little bit of open source, and then a security service like us, versus a traditional data center that's not cloud, that is usually a mix match of security tools, sometimes in the order of 40 or 50 different security tools. But there's also kind of this challenge that people that are migrating to the cloud attempt to bring legacy tools that they're used to using in-premise to the public cloud. And those tools that aren't purpose fit for this have challenges. Some people call this cloud washing, where they just take, an appliance of software, virtualize it, and call it cloud. There's also very different artifacts that you need to think about. Things like IP addresses and ephemeral workloads world change so frequently that maybe the IP address is not something that's a good enough signal to know that, how do I look or respond to an incident. You want to look at things like tags or instance IDs. So legacy tools are something you want to be aware of. The next, of course, is open source, and there's so many different. There's literally hundreds of different open source tools out there. Some of the more popular ones we have: OS Query, OSSec, SecurityMonkey, and certainly there is a place for a lot of the great open source tools that are out there, and we interoperate with a lot of these. But you have to beware of the management overhead of that. And you got to know that you're going to be able to scale over time with your teams and your expertise to manage those solutions. And then lastly, you got to make a choice. Am I going to make a decision on kind of breadth, where I can cover not just my Kubernetes, my containers, but what about my application configuration? What about my IAM policies? What about my PaaS services that I'm using? And then, of course, you got to think about multi-cloud here. So you either decide to buy multiple point solutions that are going to provide these, or you're going to look at something that's got a combination of breadth and then depth within those. And of course, there's being more and more attacks that are being talked about in the cloud. Whether it be a simple data leak from a misconfiguration, things like abuse of services like crypto mining, and then of course vulnerabilities and key or user takeovers. So although a lot of the way that attacks or the motives of the attackers aren't necessarily unique or different, they're providing and getting access in a little bit of a different way. And of course, the power of some of these centralized container orchestration systems is that you can do everything from one central plane, but that also leads you to a much larger attack surface, and that if you don't secure it properly and they get access to it, then they've got access to a centralized plane. So you got to make sure you're limiting, as Thomas said, you're really limiting your attack surface through different models like least privileges, where your developers, if someone does get access to their keys or their authentication, that they're only limited to certain things that they have access to. The other one is really a little bit about layer 8 challenges that we see in the field. We've got this kind of people problem where developers are moving super fast. Their job is really to push applications as fast as possible and add business value. And they're kind of saying, hey, security is just slowing us down. Security is, we got to move fast. We've been told we've got to dictate to move as fast as possible. We need to push stuff and provide value to the company. And then you've got security people that are like, oh, our developers, they're so insecure, they're not writing secure code, they never involve us in anything. And you can't really have this finger pointing that's happening. So, call it DevSecOps, call it integrated security, call it distributed security, whatever you want to call it. We need to really come and meet or look at models like embedding security people and security expertise within your scrums or within your teams that are building the tools, and then perhaps look at security as maybe a central governance or tooling organization that overlays on top of these distributed teams. So you can't take your traditional security models that you've had in the past and just simply move them over to the cloud and say we're good to go, or else you're going to run into some of these unique challenges. So operating security for cloud workloads is a little bit different. And the things you really got to think about that are different, if you think about visibility. So visibility is, you don't own the hardware, you don't own the network, so you got to kind of get over that. You're not racking and stacking boxes anymore. You're not baking them in some way. So because things are so ephemeral and are changing so quickly, you have to understand what you have in real time. So, there used to be a time when you could ask a security person, hey, how many web servers do you have? And they'd be like, oh, we've got, 3 racks of web servers. And, these are the IP addresses of those. Nowadays, the answer is becoming, well, it kind of depends. I really don't frankly know. How busy is our web service? Is it scaling up? Is it scaling down? Is it gone vertical? So it's really about understanding and clustering these things together, but you got to get visibility into that. If you can't get real-time visibility into what's happening, it's likely you're going to lose data. You're not going to understand what happened for a small amount of time. The next one is there's a very low degree of automation in a lot of the security tools out there. So it's very hard to keep up. As things are expanding and contracting, as people are pushing very fast, you have to automate a lot of this stuff. There's no way you're going to be able to use manual processes that you have in the past. And then, of course, security has to be run at the speed of your DevOps team. So you got to integrate those and figure out what that middle ground is between speed and safety. So let's just dive into a little bit about LACEWORK'S. So, our goal is to help customers secure their IaaS and PaaS services in the cloud through automation. We operate 100% of our service in the cloud in a cloud-native way, and we believe that if you're going to protect the cloud, you got to run in the cloud. It's purpose-fit for servers, containers, and Kubernetes. We designed it 100% in the cloud in a cloud-native way. Of course, it's really about how do we detect threats and risks and get those to you with the appropriate context and with the appropriate fidelity, and we don't give you a very poor signal-to-noise ratio. So in very large customers that we have today, they can get literally billions of events across, in AWS, across things like CloudTrail and their config data. It's a very, very busy, every single thing is getting logged. And then when you deploy an agent inside your containers or on your hosts, that's sending a lot of data. We're tracking all your applications, all your processes, your network traffic, and your user traffic. So the net is that you have a massive kind of lake of data. And we take all that data, we distill it down and put it into information based off of risk scores and based off of our classifiers and our ability to look at known and unknown attacks and shrink things like 1 billion events down to, on average, 1.5 high and critical events today that you have to triage. And you could think of our product kind of into 2 different buckets. The first one is LACEWORK for your workloads, and this includes, of course, containers, and we even support managed containers like ECS and EKS. And this is about how do I look at, the intrusions that potentially have come into my infrastructure? How do I understand if my image repo has vulnerabilities in it? But also, is it actually running? Is it actually vulnerable? How do I get visibility into Kubernetes, which I'm going to talk about in a second? Then we do things like incident response and, as I said before, file integrity monitoring. And secondly, we have LACEWORK for account security for your IAM and for your PaaS services. So this allows us to look across all of your infrastructure and all of your accounts and understand if you're applying best practices across all those accounts, but also if there are unknown behaviors that you haven't seen before that security people want to know about. So we allow you to look at that information, and then of course we will alert on it, and then you can of course triage it in the console, or we have an API where you can get the data. And of course, if you believe there's something bad that has happened, you can go back in time and understand what the cause and effect of that was. it is incredibly easy. You just have to, we have templates that you can give us read access to your accounts. So you could think of us as an ingestion engine where we ingest data via the APIs from the cloud service provider, and or you deploy our agent into your actual workloads or directly into your containers themselves. All that data comes to us in the cloud. We run it through our classifiers, and then we have a management plane and a UI and an API, which allows you to look at the events. We also fit directly into your modern workflow, whether it's your CI/CD pipeline, things like Slack for your alerts, or things like Jira to get and create tickets for those events themselves. Well, the benefits, and as we kind of touched on, it's really about how do we apply benefits in the new world order of your security teams with automation, accurate and actionable efficacy, a single pane of glass across all your cloud providers and all your containers and bare metal and potentially your VMs or your virtual instances within AWS. And then how do we satisfy DevOps? How do we allow them to still run with speed and safety? And how do we fit into their pipelines? And what's really interesting is we're now living in or moving into a world where security may get the events, but DevOps has to triage them. So if you're doing that, you have to speak DevOps languages. You have to be able to give them the right information. So I think I said before, you're not going to give them an IP address or just a username. You're going to give them an assumed role or an account name. You're going to give them the service name. You're going to give them the related events that have to maybe happen during that time via the APIs. And you're going to stitch information together like IPs and instance ID and tags. So talking DevOps and then obviously delivering the value across security and across your DevOps group. We also really look at it as you need to provide security across the entire continuum of build. So I'm building things, I'm pulling things down from my image repository, from my containers, my applications. Do those have vulnerability and configurations? But then all the way through runtime, what happens when I deploy those? Are they now vulnerable because of the way that I've deployed them in some way? Let's talk a little bit specifically about Kubernetes and containers. Kubernetes is an incredibly fast-moving technology. I would argue it's the fastest-moving enterprise open source project we've seen in a long time. If not, the last 5 years, maybe the last decade. It's very, very powerful. It does a lot of stuff for you that is great. But as it has moved very fast, there has, of course, like any great moving, fast-moving technology, there has been vulnerable aspects to it, whether it's a CVE, like the API server or the management plane or maybe etcd, or whether it's just a misconfiguration. One of the great things I think that Thomas outlined is if you go to managed mode, you don't have some of the challenges of operating the management plane on your own. But if you decide to operate the management plane, you got to make sure that it's not open without a password, or your API server isn't exposed to the internet. So we did a research report, and we found that there's literally thousands of vulnerable Kubernetes deployments out on the internet that are insecure. And that gives attackers, obviously, a playground to go and do all kinds of stuff. So just looking at some of our console screens from the LACEWORK product itself, the first one here is build. So we have the ability now to actually, you can point us and give us read access to your image repository for all your containers. We'll pull all of those containers down, we'll pull them apart, and we'll look for CVEs within there. So this is before you actually push anything. We'll see, hey, by criticality, here's the number of vulnerabilities that you have, and we will stack rank those against your repos and against your applications. And you can drill into there and say, okay, what is this? Which is this one that I have? How do I patch it? Is there a fix for it? Is there a mitigating circumstance that I can deploy as part of that? So build time is really, really critical here, of course. But the other thing we do that I think is more important is, so everybody's repo has all kinds of applications that have vulnerabilities. That's just a fact. That's just the nature of the things that we're storing within our containers and our applications. But does that mean that you have a significant issue? The answer, we believe, is no. Just because it's sitting in a container somewhere in your image repo, it's not cause for panic. It's something you want to deal with, but Really, when the panic starts is when you deploy it. When you deploy it and it's sitting in a runtime environment, now it becomes kind of a lot more critical. So the next level of that is, hey, have I actually deployed the vulnerable application that's in a container, and we can tell you that? Then it becomes a really big problem if it's not just deployed, but now you're exposed. So let's say you have something like Heartbleed, for example, sitting in your container repo, but nobody's deployed it. Well, big deal. You probably want to clean that up, but not a big deal. Then somebody deploys it. They deploy it, our runtime engine will tell you, hey, it's deployed, but there's no rule in your security groups that allows anyone to connect to it. So that's got a mitigating circumstance to it. But then, what happens if someone actually changes the security group and says port 80 or 443 is open to the internet? Now you've got a very big risk and exposure, and that you've got a vulnerable instance on your container, and it's outward facing to the web. It's more than likely someone's going to scan you, and you're going to have a problem. So we can combine the runtime or the build time, and of course the runtime aspects. As far as Kubernetes go, we have an entire way to look into your containers and into your Kubernetes. So we can give you a full map of your clusters, your pods, your namespaces, and your nodes, and we can tell you high-level statistics, like how many do you have, where are they, is that trend line going up, going down, what's the historical presence of that, or what do I have at a point in time? So how many did I have at 2 o'clock on, 3 months ago, or how many did I have at 5 o'clock yesterday? But also there's a real-time aspects that will tell you what's going on. There's things like what applications are running in those containers, but we're also telling you how all those containers and Kubernetes clusters are talking to each other. And we've got a very powerful technology called the polygraph. And the polygraph, what it does is it essentially builds a graph of all of your Kubernetes infrastructure and your containers. And you could look at that at a cluster view. You could also look at it in a namespace view, and you can also look at it in a node view. And why this is really powerful is you want to look at the communication between your namespaces and your clusters and your pods and your nodes to make sure that it's matching what your policy is. So although there are things like pod security policies that can manage these, and you can manage those via your managed service itself, or you can do it if you're running the Kubernetes system on your own. However, that's pretty new. Let's say you have a policy that, this namespace should never talk to this namespace, or this cluster should never talk to this cluster, or this cluster should never be exposed to the internet. We're going to look at that and tell you if this is happening. And you can dig into the graph and look at how the graph is connecting in real time or over time. So every hour we're actually computing a new graph. And then if anything changes in the graph, a new node, a new edge, a new cluster, a new namespace, that's a candidate for an alert. And then the severity of the change allows us to understand if it's something that is severe or not. So a real simple example is, let's say someone spins up a new namespace, they build a new cluster, they build the API server, and then they accidentally create a security group that says that it's open. So first off, we'll tell you, hey, there's a new security group that's open because we pulled it out from the config of your AWS configuration data. But then we'll tell you if people are connecting from the outside into your API via kube control. That's a big problem. That's something you want to look at, and it's an exposure that and a risk that you want to mitigate. And if you get breached, that's when really our product really shines. We're going to tell you not just do you have risks and exposures, but we will also tell you, hey, there's been a breach in some way. So in this particular example, we're going to tell you, hey, this machine at this time looks like they're running an application, and it's doing something like Bitcoin mining. So for every alert that we create, every event that is created, we have what we call the W5, which is the who, what, when, where, why. The why obviously is why did we alert? In this particular case, we tag it as possible crypto mining. The who is the user? What was the IAM constructs of that? What was the account or the role? Or maybe what was the SSH user? The what I'm going to dig into a little bit here, and the when obviously is the timestamp of the attack. The what is really critical. The what is where we really talk DevOps and cloud language. This is where we're going to tell you what was the instance ID, what were the tags, what was the Kubernetes node, what pod was it part of, what was the namespace it was part of. All of that data is presented in the what, And that's really important because if you want to go clean it up or triage the event or look at forensics around it, the what aspect is going to give you all that information. Versus kind of the traditional security tools that may say something like, you've got an infected server and here's the IP address. Well, what happens if you get that alert, or you don't triage it until 3 days later? That IP address may not even exist anymore. So we're going to give you the right amount of context and fidelity and alert that will allow you to go triage it properly and really talks DevOps or DevSecOps. We also give you a picture of the polygraph just for the attack or the breach. So in this particular one, you can see, someone logged in from Virginia as the Ubuntu user. They then ran Bash. They ran a new application we've never seen before. And they connected out to a mining pool that has never happened in the infrastructure. So in this particular case, we're going to know about this. There's probably some tools that are provided by your cloud provider also that may tell you that this is happening. But there's also an aspect that maybe they install an application that there is no hash or fingerprint for. Maybe they're doing things like tunneling it through Tor or through a VPN service or through a known API. So there are interesting tricks and techniques that the attackers are using, and we have the ability to look at the way that they're doing it if we know it's bad, but also if it's unknown, we've never seen it before. It's something new in the infrastructure that's never been seen before. Those are the ones you really want to pay attention to because they may be unique or novel. So, when we think about our product, and you're thinking about, do I need something for my cloud and Kubernetes and my containers? There's a few ways to think about how do I prove that it's a good product or a service. The first one obviously is, you can listen to webcasts, you can get demos, our sales and SEs can walk you through what it looks like, white papers and everything else. And that's great. The second one, of course, is you can talk to referral customers. You can look at the customers that are using the product. Do you have a connection to one of these customers, or can we provide a reference to you? This is obviously an example of that. We've got some excellent reference customers and some great touch points from third parties like Gartner, for example. But the one that is the most valuable really is running a POC or a POV in your environment. So you could do it in full production if you want. It's very little, very low overhead. It's very simple to set up. Usually takes anywhere between 10 minutes, to a half an hour. You can deploy our agents or give us access to your roles. And we do a 30-day free assessment. At the end of the 30-day, you're going to get a pretty deep analysis, depending on what you deploy, anywhere from 25 to 50 pages. And we're going to list out kind of all your risks and exposures across your cloud, across all the compliance checks we're doing, but also across Kubernetes and containers. Do I have vulnerabilities? Do I have instances that are vulnerable? Do I have potential configurations? So that report is a really valuable way to understand the value of the product, and typically it's part of our sales process. We do a demo, they do a trial, and then of course based off of the trial, they decide whether they want to buy or not. So if you are interested, I highly encourage you to go to lacework.com and /free or /trial and do the trial, frictionless. You can go there and do it on your own and get the value of the product there. So with that, I think I'm going to hand it back for questions from the audience. Looks like we've got a few here.
All right, so just a reminder, folks, for anyone who hasn't had a chance already to go ahead and enter your question in the Ask a Questions tab at the bottom of the screen, and we'll get to them as soon as we can. We do already have a handful that have come in, so we're going to go ahead and get this thing started. The first question that I have here says, is LACEWORK able to detect misconfigurations in AWS security groups?
Yes, yep. Because we pulled the data in, we're looking at your configuration data in real time. And there's a couple of ways that you think about that. One is, are there things we know are kind of legitimate misconfigurations that you want to be aware of? Those are kind of a static set of checks that are common across all customers kind of globally. And you can decide to suppress those, or if they're important to you, you can look at them. But then we also have the ability to look at misconfigurations that are unique to you. So these are behaviors and anomalies that are not common within your infrastructure that you want to look at. And those are different based off of every customer. Every customer's cloud configuration is probably unique to them. So in those cases, we can look at the known and, of course, the unknown. And that really fits, I think, more into the risk and exposures than it does into the threats. You want to really know what are the risks and exposures, and then you want to make sure that the developer meant to do what they did, or the person that's running the service meant to do what they did, and then close that ticket and just note it as something that it is fine, that we're okay going forward with.
All right, awesome. So the next question I have here says, how does LACEWORK detect AWS open S3 buckets?
So this is very similar to the last question. Open S3 buckets has been an issue for some time. Kudos, to AWS, where they've really done a great job at building the interface and making it a little bit more clear that something's open, it's default off. There's a number of great security constructs there, around encryption and making sure it's not open to the public and things like that. But if you do have an open S3 bucket, we will detect it, through your configuration. And what we do is we'll tell you via an alert and say, not just this S3 bucket is open, but maybe it's configured in a different way. Maybe it's open to the world, or maybe it's only open to these users. The other interesting thing is that there's also a perfectly legitimate reason to have S3 buckets that are open. Certainly, you can't have a blanket policy to say, well, I guess you could, but it's pretty rare that we run into customers that say, no one should ever have an S3 bucket that's open. There's all kinds, you may have a repository of PDFs for your website there. So you can do it down at the resource level, and our checks go all the way down to the resource level, where you can check and say, hey, okay, maybe by default we want to know about all open S3 buckets, but for these ones we know absolutely it's fine that they're open. But what we don't want is them to be world writable. So anyone can go in and change the permissions or delete a bucket and do things like that. So it's very configurable from the administrative perspective.
Awesome. The next question I have here says, how does LACEWORK improve Kubernetes visibility?
Yeah, so I went into that a little bit. I think one of the great things about our product when people deploy it, the first thing is usually when they deploy in a POC, we bring up the UI and we show them the polygraph. And in a great kind of sales scenario or prospect scenario, you've got the DevOps person in the room and you've got the security person. And they look at the screen and they're like, oh, wow, I didn't know we had this many namespaces, or I didn't know this many clusters existed. Or they, I didn't know this cluster talked to this, this cluster, or this namespace had pods that were connecting to these pods. So there's a great level of visibility in a way that talks Kubernetes, and it provides a really good starting point for the DevOps people and security people to start talking about why it's set up this way. And it's really hard without that kind of grander picture of how everything is set up and configured to have that conversation without going to a whiteboard or talking about it, but actually looking at the data is really, really powerful. The other thing that's really cool is when we do alerts, or if you want to query for data, I can't do a demo here, but you can literally, we have global search, and you can literally go in and type in something like Kube API, and we'll list out all the containers that have the Kubernetes API on it. We'll tell you when they had the API, if it was open to the internet, if it wasn't, who's connecting to that API, what machine it's on, what instance it's on. So you can actually search for things too, whether it's Kube API, Kube control, the Kube management server, etcd. So all those things are world searchable also.
All right. The next question I have asks about, how does this do build time container security?
So build time, or some people are calling this shift left, which is, if runtime is on the right, facing, a whiteboard or a screen, then on, the left-hand side is really about continuous integration and deployment. And how do I shift left and start kind of building my security processes before I deploy? and fitting into that process, and then hopefully automating that. So what we announced actually at the Reinforce show, which I think was about 3 weeks ago, which by the way was an incredible event. It was amazing to see so many people just focused on cloud security. And if you're not planning on going next year, I highly recommend Reinforce next year. We announced that we now don't just do runtime, we actually have the ability to look at the vulnerabilities within your image repositories for your containers and your applications. And then as I kind of briefly talked about in a couple slides, comparing the net of build time and runtime as you deploy stuff.
All right, I have one last question here, and the person is asking, can this integrate with my CI/CD solution?
It can. We haven't released our API yet, but we'll soon be releasing our API to the container vulnerability information. And with that, what you would do is you would pull our API, and you would be looking at your scan, essentially our scans of your containers in your repos. And from there, you would be able to take our vulnerability data and then decide whether or not you want to integrate it directly into Jenkins or whatever deployment mechanism you have. And then it's up to you whether you want to stop a deploy, you want to triage it, you want to push it, or you want to just have that as informational. So really, you can do it now from the management console and looking at the dashboard, of course, itself and getting the alerts that way. But very soon, you'll be able to actually automate all that through a set of APIs.
All right, great webinar. Lots of great, interesting information. So I did want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or you just want to listen to it again, just know that you'll be able to do so on demand. We will be sending out an email that will contain a link to the webinar on demand. The webinar is also going to be living on the DEVOPS.com website, so you can always check there. And then while you're there, you can check out the other webinars that we have, both upcoming and on demand. Hopefully there'll be one or more that pique your interest. For now, though, I'd like to thank you for joining me today, and thanks to our esteemed panelists for joining me. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.